Let's look at arithmetic expression before we start off with the next topic. So the next topic has to do with something like this, simplify this particular expression. Is 5u and 5 plus u different, and how to simplify this, so on and so forth. To understand this, we need to go back to numbers. Okay, so why is that we are going back to numbers? Remember, variables are nothing but just placeholders for numbers. And it need not be the same number, it can be different number. I mean, it can be 2 and 3 or any pattern like 12 and 13, so on and so forth. So this can be variable A and this can be variable B. Right? That's the power of variables. And we got to see that with different scenarios, and we also used it in our coding as well. Now, let's recap how numbers behave. So if we understand how numbers behave, we can use the same behavior to this as well. Okay, so we can make use of the same analysis or the same behavior to variables as well, to simplify them, to simplify such things. Now, we are starting off with something called as commutative law. So we have 83 plus 28 minus 13 plus 32. It's the same as this is what I have written. Is that true or false? Answer is true. So I'm shifting 28 and minus 13. So minus 13 comes from and plus 28. This is a sequence. But why are we doing this? Because 83 minus 13 is much easier to subtract, and 28 plus 32 is much easier to add. And so we do this commutative law. I hope you guys remember about commutative law. Commutative law, commute means what? Commute is about movement. So I can move the terms as such. And remember, minus 13 is not the same as 13. So we have to shift the symbol as well, the sign of the number as well. Okay, so it's important for us to shift numbers with sign. Again, guys, all of this is useful for your variables as well. So everything has to be remembered. Everything has to be thoroughly understood. Now, so let's make use of board mass, additive inverse, and distributive property. Let's recall all of this, make use of that, and apply it to our variables as well. So eventually we'll be learning all of this in this section or the next section. So I have mixed it up, right? Now, consider that we need to simplify this. We can do it in two ways. One, use board mass, and then use additive inverse. First thing is, what is additive inverse? Additive inverse has to do with minus 18 is same as minus 18. So this is supposed to be read as minus of 18 is same as minus 18. If I have negative sign outside the brackets, I should take the additive inverse of whatever is there inside the bracket and write it. So additive inverse is nothing but, if I have 10, additive inverse of 10 is minus 10. So if I take a number and the additive inverse of that, it will always be equal to 0, right? So here 10 and minus 10 are additive inverse of each other. So let's make use of board mass, that is using brackets, operation, division, multiplication, addition, subtraction. I hope you guys remember how to use this. Okay, we have brackets, yes. I'll simplify this. So this is equal to 5. Now, this is supposed to be 68 minus of 5, which is equal to 68 minus 5. That is, I'm taking the additive inverse of 5 and writing it outside the brackets. That's what this sign tells. Take additive inverse of whatever is there inside the brackets, right? After that, if you after considering that, you need to write it without the brackets, and that is your simplified version. And so the answer is 63. So in general, remember, when we relate this to variables, in general we have minus of a is minus a, minus of minus a is plus a. Remember, variables are just placeholders for numbers. So whatever behavior you see over here, right, over here we saw that. Same thing I'm applying to variables. Instead of writing 18, I've written a. Instead of writing minus 13, I've written minus a. As simple as that. Now I can simplify the same question in another way. That is, use distributive property and then additive inverse of at the same time. That is, I'm using distributive property first. I'm rewriting minus of 18 plus 3 as taking the additive inverse of 18, that is minus 18, taking the additive inverse of plus 13, that is minus 13, and substituting it over here. And then using board mass. We don't have brackets, operation, division, multiplication is not there, addition, subtraction is there. So I'll move from left to right. So left to right, 68 minus 18 is 50, then subtraction, so on and so forth. So subtraction and subtraction again. So this is how we can do it. So remember, in general, what we're looking at is, if I have minus of x plus y, for example, I can write it as minus x minus y. Or let me give one more example. If I have x minus y, so additive inverse of x is minus x and minus y is plus y. So you just have to take the additive inverse and write it outside without the brackets. So is inside the brackets. To complete this, and write them without the brackets. And that's that. So what is that we are doing here? We are revisiting two things, commutative law and distributive law. Commutative law tells that you can shift around numbers. Right? We can shift around numbers and use your simplified version, then use your addition, subtraction, multiplication, division, and so on and so forth. And then you do the result. Find the result. So commutative law is applicable to only certain things. All of that information has to be very clear. So I'm just giving a quick recap. So there are certain rules that has to be continued, that is not changing. If you guys want commutative law exclusively, then you have to go back and do that. Now, distributive property. So I am not talking about distributive property when there is a positive sign outside the brackets. So I'm just directly talking about negative sign outside the brackets. So in this case, we need to take additive inverse and then simplify. So another way of doing this is using distributive property first and then additive inverse later. Actual thing is, first additive inverse, later is the right heading. And so it is applicable to variables as well. Remember that it's applicable to variables as well.